In a survey, the survey, 1,200 people's IQ scores were recorded. The mean score was 100 points, and the standard deviation was 15 points. Assuming IQ scores are normally distributed, fill in the missing numbers. No bother. 100 in the middle, 115, 130, and 145. 145 is very rare, that's why the height isn't that tall. While IQ of 100 is quite common, it's the most common. It's the mean, the mode, and the median. Okay? Then we also have a score of 70, and likewise a score of 55, really, really, really rare. Now, the person is chosen at random from those surveyed. Use the empirical rule to find the probability that a person has an IQ between 70 and 130. Now, guys, we're quickly going to revise this. One standard deviation either way, what's the percentage? 68. Two standard deviations either direction? 95. Three standard deviations either direction? 99.7. You'll only ever be asked about the 68 or the 95. You guys will. So, what do we reckon? In between 70 and 130? 95%. This is known as the empirical rule. Two standard deviations above the mean, two standard deviations below the mean, always 95%.
What is it again? But the extra one. So 68 and then but the extra one.
One standard deviation below, one standard deviation above, 68.
And what's the next?
Two standard deviations below, two standard deviations above will get you 95. The gap in between.
And then if there's only like one.
Oh, I get you. So what Sam was sort of saying was, being reasonably inventive, what he's saying is, imagine you did 115, 70 to 115. So the area on the left would be half of 95. So half of 95 would be 47.5, while the area on the right would be half of 68, which would be 34. And then if you add both those scores together, you'll get I get what you're saying, 81.5%. All right. I'd be surprised if they tried that, because it will take a lot of people out while they sort of want to give you marks. But it's good that you can do it. Okay. Now, how did he do it here? Use the empirical rule to find the approximate number of people surveyed between 85 and 115. What's 85 and 115? 68. Now, that's not the answer. That's the percentage, but it's not the answer. 68% of how many people? Yeah, and what's the answer for that then? Anybody get it? Knowing you probably got it right. 816. Yep. Alright. So this stuff is easy money if you remember. Okay, it's easy stuff. Now, this is part B. A class of 24 pupils made up of 10 boys, 14 girls. A chemistry is studied by 6 of the boys and 9 of the girls. A pupil is chosen at random from the class. Find the probability that the pupil chosen is a boy or is a pupil who does not study chemistry. Alright, I'm going to do a pie chart, or sorry, a Venn diagram. And a Venn diagram will make things easy for me. Okay? Now, will it make things easy on me?
No.
It might do. I have an idea. Boy, chemistry. Oh, boy, girl, chemistry. Yeah, triple. Boy, girl, chemistry. It's impossible to have a middle, isn't it? Why is it impossible to have a middle? Huh? You can't be a boy and a girl at the same time.
Are you sure?
In this case, it's not going that way, but I get it. It could be possible, but there's no specification that this is the case. All right. All right. Before I engage in that, I might just try writing stuff down, all right? 10 boys, 14 girls. Okay. 6 boys and 9 girls do. What do they do? Chemistry. Okay? Grand. This means that they do chemistry. So this means that, so the way I do this is six boys here, because they're in the boys and they're in the chemistry region. That makes sense? Then I'd have 9 girls in here, because girls that do chemistry and girls. Then we have 5 left over because they don't do chemistry. And then we have 4 boys left over because they don't do chemistry either. Is that alright? Now, find the probability that the pupil chosen is and there's a class of 24. So there's people on the outside that do none of these. Now, this diagram doesn't work. Why does it not work? It isn't actually the outside. It's yeah, I can't do the Venn diagram because if it's outside the Venn diagram, it's yeah, that sounds about right, Sam. I won't do the Venn diagram. It was a bad choice because I would have had to put somebody outside the Boy and Gara region, and we're not going down that route. Now, that's going to do chemistry. So no chemistry is 4 and 5, 4 boys and 5 girls. Is that all right? Now let's write this. Probability the pupil chosen is a boy. Okay, how many of them are boys?
10
out of
24.
Or is a pupil who does not study chemistry? Well,
9 and 24.
yeah. No, it's the girls. 5 out of 24. Why can you not include the 4 out of 24? They're already included, aren't they? So when you're including the 10 boys, you're including the 4 boys that don't do chemistry and the 6 boys that do. Or a pupil who does not study chemistry. But then you should also include the 5 girls that don't study chemistry. And the answer is 15 out of 24, which is, anybody? 5 out of 8. Anybody get 5 out of 8? Use the marker scheme or wherever else. Huh? Yeah. Best not to do a Venn diagram on that one. Sometimes it works, sometimes it doesn't. Alright, let's move on. Is this the next question? Alright. Can anybody tell me what you got for this section here? You just get your total votes and take away the other 3 items, is it? Or is that right? No. Alright.
No, just valid. It's just total votes minus valid votes.
Sorry, yeah. It's total minus valid. So, that's a good point. So, lads, it's just the total votes minus the valid votes. Because the votes are either valid or invalid. One or the other. Who got that score then? Sorry, what's the first one? Bear out loud. 359. Awesome. Right, Grant. Done. Write down the number who voted to leave the EU as a percentage of the valid votes. So how many voted to leave? That much. 17,410, 742. And how about that to divide that by? The number of valid votes, which is
17.
did I? So 47, is it?
It's 17.
Ah, call that one more time. 17,410 and 742. Multiply that by 100 and what do we get? 52% rounded up. So far not so bad, is it?
So if you put that over, that's the only way you can find it.
Yeah, it's the way you find the percent. Just your number divided by your total multiplied by 100. Alright. This B, is it? Now, do you want us to do a table? The table shows the percentages of remain and leave voters in the various groups of those who voted in the referendum. How would you display this data? I decided to display this data as a bar chart. Is everybody cool with a bar chart? And I'm grouping them in their age categories. So it's percentage It's percentage on the on the y-axis, and it's the age demograph on the x-axis. Blue is the number who want to remain, and red is the people who want to leave. Do you know there's any trends? Younger people want to stay, and older people want to leave. That makes sense? The older you are, the more likely you are to want to leave. Okay? Now, what's part C then? Is this part C? Oh, is there? Is that it there? Alright. Find the mean of the remain values given in table 2 and find the mean of the leave values in table 2. Give your answers percentages correct to the nearest two decimals. I'm just going to get rid of this chart. Okay. So just average them, is it? So this way, add all the yellows and divide by, and then add all the greens and divide by, and what you get is your two means. 52.3 and what else? 47.6. Is everybody happy you just averaged the two of those data sets? So 52.3 and 47 points, and that's in the right place. All right. It says two decimal places. Thanks. Remember not to do that in the leaving cert. If you can help it, just make sure you give it exactly as it asks it for. Okay. Explain why the answers in B part 2 do not accurately reflect the outcome of the referendum. Why do they not accurately reflect the outcome of the referendum? Well, let's find out. Very easy. Imagine this, guys. Not every group is going to have the same amount of people. Generally speaking, the most numerous group is the younger group, isn't it? So just for argument's sake, imagine this. Imagine 100 people are in this age group. Actually, wait, I'll make this a bit easier. 200 people are in this age group. 100 people are in this age group. 100 people are in this age group. Actually, sorry, I'll go one more time. Sorry, I just want to make really easy numbers. 100, 1,000, 500. Generally, the younger you are, the less likely you are to be dead by now. So, generally speaking, there's more younger people than older people, all right? So I'm just making up a couple of numbers to reflect this. Right, that's 400. I'm over exaggerating it as well. Now, if you broke up the numbers like this, and what you can say in the test is, generally speaking, younger people are more numerous than older people, and 40% of the younger people is a much bigger score than 40% of the older people. We're all worth the same amount of votes, aren't we? So if I was to use this sample here, this would be 730 votes. Well, that would be 270. And then if to go for this one, what would that be? 310. And that would be, what's 5 times 38? Sorry, 5 multiplied by 38. What? 190. Okay? And then, what's it? 52% of 400. You guys just get the percentages of the numbers I put to the left. We're just going to add them up. Just to show you an example of why it doesn't always work. Yeah. This one? Oh, sorry, that'll be then. That one's 192. Let's do the ones on the left and I should be able to make it happen. What? No, 44% of 300. Thanks. And then that has to be 160. So 168. Then this one. And then here. What? 114? Yeah. And then the last one is 40 and 60. Who won the vote? If we split this down the middle, who won the vote? All day long, Remain won. Why did the Remain win? The 730. So what you're saying is a high percentage of a more numerous demograph is better than a high percentage of a demograph that isn't as big. A high percentage of 1,000 people is much better than a high percentage of 100 people. Does that make sense? So the way you'd write this answer is, you'd say that average does not reflect how many people vote in each age interval. So basically, younger ages are more numerous, and they will influence the vote more than 70. And you can say 70% of the younger demographic will influence more than 70% of the older demographic, because they're more numerous. Okay, that's the point I was trying to hit home. Now we move on. All right. This question here, is that the next one? Is it? Yeah. All right. In the days following the UK referendum, this is an important one. A survey was conducted in Ireland on attitudes towards the British exit from the European Union. 1,200 people were surveyed. Find the margin of error of this survey. Anyway, what's the margin of error? Which is 1 over root 1,200, which is 0.03, which will round up to 3%. Is that okay? Now, the Irish survey 578 out of 1,200. So what do you get for that? Once again, in percentage. 0.48, which is 48%. If you read the question, it will tell us to construct the 95% confidence interval. Okay? So 48% of the population agree it has a negative effect. But did we interview the entire population of Ireland? We only interviewed 1,200 people. So there could be an error in what we said. So to prevent this, to give us a bit more margin, what we do is we take away 3% and we add on 3%. And we say that we're 95% certain that the real answer is somewhere between 45 and 51 when we survey 1,200 people. Is that okay? Now, we're going to do the hypothesis test next. Yes? Wait till after this. Okay? What's H0? It's known as the null hypothesis. What does that mean? Null means nothing has changed. So what do we say? We believe 53% of the Irish population believe Brexit will have a negative effect. Is that right? Now, what's the alternate hypothesis? What's the alternate hypothesis? Must have been lazy here. Now, the alternate hypothesis is quite simply, see the way I say believe? What's the opposite of believing? Do not believe. Or yeah.
So those kind of questions there at the end, like
yeah, change the word. One of them it is 53 and the other one is it's not 53. Oddly enough, in the American scheme, it's just like this. P equals 53, and then H1 is P is not equal to 53. Alright? Now, what do we know about our confidence interval? It's 55 to 51. Is the answer in this region? So what can you say? 53% is not in the 95% confidence interval. So what does that mean? Which one's correct? H1 or H0? Yeah, so you reject H0, and what you say is, we reject H0, and then you're done. Because you know it's not true.